Hey guys, welcome to our first lesson where we are going to be really talking about graphing quadratics and what that looks like and all that good stuff. So on this Desmos activity, the first thing I want you to do is go to Desmos and I want you to type that in. And so I have done just that, and we're going to talk about some stuff here. So let me get this. So I type this in and you'll see that it looks like this, and that's called a parabola. So anytime you have an x squared right here of any kind, that is a quadratic, and it is going to make a parabola. So let's kind of talk about some main things. So if I were to look at the bottom right here, this is called the vertex. And so our vertex is going to be 1, -5. Something else that you should be familiar with is right here, that's where it crosses the y-axis. It crosses it at 0, -3. And this thing that you see over here called AOS, that's called the axis of symmetry. And what that does is it cuts it in half. It's actually a line. So that's why it says like y or x equals. And it's always going to match the vertex, the x value of the vertex. So the x value of the vertex is 1. And so our axis of symmetry is going to be x equals 1. So do you see how it cuts that parabola in half? That's what we want. So our axis of symmetry is 1. Okay, something else I want you to see is that as we zoom out, do you see this parabola? It gets really, really high, but it also slowly goes out and out and out, like more and more and more. It goes to the left and to the right. It's kind of hard to see because it goes up so far, but it goes like way to the left and way to the right as we approach infinity. So what that means for our domain is always our x value. So since it goes to the left forever and to the right forever, all parabolas will always be the set of all reals. Okay, your range deals with your y values, and we're going to grab the y value of the vertex. And if it opens up, it's going to be y is greater than or equal to whatever that y value is. If it opens down, it's going to be y is less than or equal to whatever the y value is. So if you'll notice, since it opens up, we're going to say y is greater than or equal to -5. Okay, the next thing I want you to notice is that we can go to this little tool bar right here, and we can create a table. We always want to put our vertex in the middle. So we're going to put a 1, 5 here, and we're just going to work around the vertex. So I'm going to say 0, -1 on that side, and then 2 and 3 on that side. Okay, if you set it up like this, these values will always repeat and these values will always repeat. So we'll see this here in a second. So look at this, 0, -3, but also 2 has -3 as a y value. And that is not a coincidence. Like, it will always be like that. Let's go to -1. So -1, +3. And if I typed in 3 here, it would also be +3. So I have everything I need to create my graph. So I'm just going to plot my points. I like to start with the vertex. So 1, 2, 3, 4, 5. Let's see, we have 0, -3. And we have, oops, sorry, I wrote that down wrong, didn't I? It's 0, or it's 1, -5. Let's that up. Let's see, 1, 2, 3, 5. And then we have -1, 3, 1, 2, 3. And we also have 3, 3. 1, 2, 3, 1, 2, 3. So we are going to, oh gosh, that looks terrible. So the parabola kind of goes down like this. Sorry, not doing a good job of drawing on that, but you get the idea. Okay, let's do the next one. So let's go up here, and I am going to type this into Desmos. And if you'll notice, this one goes down. Let's see what else we can see. Oh, so there's our vertex. Our vertex is going to be a 0, 8. And our axis of symmetry is always going to match the x value of our vertex. So like right here and right here, those are always the same. This one is unusual because it's also where it crosses the y-axis. So these are also the same. But that is not always the case. Okay, the domain is always going to be the set of all reals. And then since it's going down, our range is going to be y is less than or equal to, and then I'm going to go up to the y value of my vertex and say 8. So I'm going to plug in 0, 8 to the middle part, and I am going to go to my little cog here and fill in the rest. So let's see, 0, and you might have to like add the numbers if it doesn't show up. That's not unusual, but these give us a nice start. So remember, I know that these two are the same, so I automatically know this is 0 and this is 6. So let's see, this would be -1 and -2. Okay, I think we have everything, so I'm going to go ahead and graph it. Let's see, we have 0, 8, 1, 2, 3, 4, 5, 6, 7, 8. And then we have, let's see, 1, 6, and -1, 6, and then -2, 0, and 2, 0. Okay, so let me go ahead and write this down. We'll talk about this. Another thing that I want to say is these right here, these are called, those are our x-intercepts, but they're also called our solutions. So if we just got out of a unit where we were solving for an equation, this is exactly what we're finding right here. We were finding where it crosses the x-axis. Okay, let's go down to the next one. So these are actually what we're going to focus on in today's lesson. But go ahead and type these two into Desmos and see what you get. Okay, guys, here are the graphs for 3 and 4. Notice how 3 is negative here, and it makes it go down, where 2 is positive and it's going to go up. So that number in front really makes a difference. The axis of symmetry, if we're going to label it on the graph, it's going to be like a dotted line through the center. And the range, notice, okay, so first of all, the axis of symmetry will always match this. So axis symmetry will always match the x part of the vertex. And then your range is always going to be either greater than or equal or less than or equal to the y part of your vertex. So if it's going down, it's going to be less than or equal to. If it's going up, it's going to be greater than or equal to. Okay, so we are going to go back to what we did last unit. So think about if we were to like solve something, we would have to first factor it. And so I have, let's see, -16 and 6. So two factors of 16 that kind of feel like they subtract to give you 6. So that's going to be, let's see, 8 and 2. And so I'm going to say -2, and I can do the shortcut here. So it would be x plus 8, and then x minus 2. And we would set them both equal to 0. So x is equal to -8, and x is equal to 2. Okay, so Desmos will actually do this for you, but you have to know where to look. So let's go ahead and type that into Desmos. Okay, so notice if I just type it in as I see it, I get just two straight lines. I get -8, 0. So it'd be like x equals -8. So let me write that down. X equals -8. And then I also have, let's see, x equals 2. So that's totally fine. Another way to look at this is kind of like as a function, like we have been, like, so an actual parabola. And notice it goes through the same spot. So either way, if you want to look at this as a y, or if you want to look at it as a 0, it doesn't matter. That's what we're finding. These are actually called the zeros of the function sometimes, as well as like the solution, or they're also called like the x-intercept. So they have lots of different names. Okay, let's go ahead and do this next one. Let's see. So we have 8x and then -20. And I kind of prefer the y, but either way, just make sure that this is set equal to 0 if you're going to do it that way. Okay, so then I have x equals -10, and then also x equals 2. Like that. So that's how we used to solve. And again, if I just made this a 0, you're going to get the same answers. It just doesn't look like a parabola. It's just like straight lines. Okay, so the next part, standing on a cliff, I threw my marker into the air. The height of the marker is modeled by the equation, and then it gives you the equation. Identify the following from the Desmos graph. Okay, so I'm going to go ahead and type this in as I see it. So y equals -x squared plus 6x plus 16. Okay, so kind of think about where we just came from. So if you're starting here, all of this over here is negative time. So I don't really care about that. I don't know if I can, yeah, so we're just gonna like pretend like it's right here. And so the marker is gonna go up in the air to a certain part, and then it's gonna go down until it hits the ground. And the ground is right here. Okay, so let's kind of answer the question. What is the maximum height? So the maximum height would be 25 feet. Okay, the time at the maximum height. So that took 3 seconds to get to the maximum height. The total time in air. So it started right here at t equals 0, and it's going like 1,001, 1,002, and it takes until 8 seconds to get on the ground. So 8 seconds. The height of the cliff. Okay, so I chucked my marker off this cliff right here, and I was 16 feet high. And so that's how you answer those questions there. Okay, number 8. A basketball is tossed upward from the top of a 28-foot gym balcony. Okay, so this one doesn't get, it just gives us the generic formula. So we need to know where to put this in. Okay, so S, that's our starting height. So that's 28 feet. The initial velocity, that's going to be 18 feet per second. And then write the equation that models the height of the basketball. Okay, we just kind of did that. How long was the basketball in the air for? Okay, so I'm going to type -16t squared plus 18t plus 28 into Desmos. And for some reason, Desmos allows you, it doesn't allow you any other time, but it allows you to do the h's and t's if you want to. I'm not sure why, but anyway, we'll take it. So I'll just show you. If you want to use X and Y, totally fine too. Okay, so I typed this in. Let's see. So it looks like this. And I'm going to zoom out a little bit. Okay, so how long was the basketball in the air for? So when it's asking for in the air, it's asking for, okay, it started right here. Let's see, where did it start? Right here, 28. It went up in the air and it went down, and all the time was going. And so it took 2 seconds to land on the ground. So 2 seconds. Okay, and then finally, this last one, a rectangular playground has a length that is 5 meters longer than its width. Okay, so let's think about that. So we just had problems like this. So this is W, and this is W plus 5. And you know the area is 84. Okay, so I'm going to say W times W plus 5 is equal to 84. So let's just kind of type it in as we see it. And this one you definitely cannot use W, so I'm just going to use X. Okay, and so notice it goes set this equal to 0, or like subtract, like, yeah, set it equal to 0, so subtract the 84 over, and then we can write it as a parabola, and it's going to give us the same answer. So we have negative 12, and really I don't care about that negative 12 because we can't have a negative number. So I know that our width is going to be 7 meters. So if our width is 7 meters, then I'm going to plug that 7 in right there, and 7 plus 5 is 12. And so our length is 12 meters. Okay, that is it, guys. Thanks.